is different than your car engine or vehicle engine for the most part. Not because of liquid nitrogen. But the main difference is there's no combustion inside the engine. So one of the things is there's a Scandinavian company which actually builds a stealth submarine that uses one of these. Also, and the power plant is secret. You can download the PDF document it fits on like a big poster for selling it to countries. You want to impress the admiral when he comes and sees it, so you make a PDF file and you print posters for like a weapons convention or that. But the power plant is actually crossed out, it says top secret. So what they do is they probably use seawater in comparison or differential with some other material. So it doesn't really hurt you if you get the stuff on you. You just got to be careful. There's insane people who will actually drink this stuff. I never, recommend you never do that. It has a bad effect after a while because the gas sort of expands in large amounts. So what this will do is this will run actually on the air in the room, and what it's going to use is the temperature differential between the air and the reservoir now. So it's 20 degrees Celsius compared to the boiling point of liquid nitrogen, which is 77 Kelvin. So it's 300 Kelvin versus 77 Kelvin. So that temperature difference will actually cause the gas, which is just the air in the room here, to fire this up and see how much luck. I did not try it before, so we'll we also can run it on a heat lamp, just a alcohol lamp or other heat source, but we'll put some more in there. It boils off because of the temperature is really very hot and starting. I'd start to move on its own now. I want to go the other way right now. A little better than watching paint dry. At least you got some little event here. Let's see. So that'll now run, and so the great thing about it is there's no combustion. It's really good for the environment, right? You had that problem in your last class about the global warming. In some sense, there's some issues there. We'll be talking about that with heat engines. But this is actually a really good system because as long as you have a temperature difference, you can run this. NASA actually uses these with solar energy. You have a big reflector that actually focuses the heat, gives you a temperature difference. And this one is built by our machine shop here. These are also used as refrigerators in high-tech labs, research labs. Because what you can do is, what if you put a motor on there, you compress the air and change the temperature that way. It's one of the things we're going to be doing in this class. So this is a Stirling cycle. And so it's actually a practical system here. And so the other thing you see here is you're actually getting some work out of this system. Okay, so let's go back and do a little more here. So how would you do the work for this engine? What's making it actually produce this energy, this work? So you compress the gas, right? You cause the gas to change its volume, and that actually makes the propeller run our little thing. So here's our little demonstration. It's pictured here with the actual heat source on it. And we'll show you, there's another sim you can play with an engine. Here's sort of like car engines, this is what things look like on the inside. I can show you this that temporarily. But this is sort of the mechanism.
You ready to program?
So what's happening is the air actually is drawn in. This is a combustion engine.